A warm welcome all of you. Myself M. Kandasamy, Assistant Professor, Department of Mechanical Engineering from Sri Shanmugha College of Engineering and Technology. Today I would like to teach about engineering thermodynamics. First, definition of thermodynamics. It is the branch of physical science that deals with the relationship between heat and other energy like as mechanical, electrical and chemical energy. The another way of definition for thermodynamics, it is the science of the relationship between heat, work and the properties of a system. Next, I am just telling about briefly explanation for thermodynamics. Thermodynamics is derived from two words, thermo, which means first one is thermo, which means heat energy, and another one is dynamics, which means conversion or transformation of energy. The next topic is system, surrounding and boundary. First, definition of system. System is defined as a thermodynamic system is defined as a definite space or area on which the study of energy transfer and energy conversion is made. The definition for surroundings. Everything outside from the system which has a direct bearing on the system behavior. The next one is boundary. The system and surroundings are separated by boundary. It may be fixed or movable and real or imaginary one. The next topic is types of system. I am already explained what is meant by system. Once again, the a thermodynamic system is defined as a definite space or area on which the study of energy transfer and energy conversion is made. Now, there are classified into three types. One is isolated system, closed system, and finally open system. In isolated system, there is no exchange of matter or energy. In closed system, there is no exchange of matter but some exchange of energy. In open system, exchange of both matter and energy. The next topic is processes in thermodynamics. The definition of processes, a series of action or steps taken in order to achieve a particular end. Here, the types of process are reversible and irreversible process. First, a reversible process. The explanation of reversible process. A system passes through an infinite number of continuous equilibrium state, and if it traces the same path, when this process is called as reversed process. And another one is irreversible process. The same like as reversible process, but it does not traces the same path when the process is reversed. That's all. Okay, just I am telling about some example for irreversible process. When we are driving the car uphill, consider when we are driving the car in uphill station, it consumes a lot of fuel, and this fuel is not returned when we are driving down the hill station. Okay. The next topic is control volume. Control volume is defined as a volume which encloses the matter that the device inside a control surfaces. The next topic is properties of thermodynamics. Okay, what is meant by properties in thermodynamics? The answer, the property of a system should have a definite value when the system is in a particular state. Thermodynamic property is a point function. Dear students, here functions of properties classified into two types. One is point function and another one is path function. First, what is meant by point function? The quantity which is independent on the process or path followed by the system is known as point function. For example, pressure, volume, temperature, etc. And explanation of path function. The quantity which is dependent on the process or path followed by the system is known as path function. For example, work transfer and heat transfer. The property is classified into two types. One is extensive property and another one is intensive property. First, extensive property. The properties like volume of a system that depend on the mass of a system are called as extensive property. Example, mass, volume, length and total charge. And also intensive properties. The properties like pressure or temperature which does not depend on the system mass are called as intensive properties. For example, melting point, boiling point, pressure, molecular weight and density. Students, the next topic is equilibrium. The definition of equilibrium: a state in which opposing forces or influence are balanced, or a state of physical balance. When the property of a system is defined, it is understood that the system is in equilibrium. Equilibrium means what? Balancing in equal side. Okay. The next topic is work. The definition of work. Work is defined as the product of the force and the displacement in the direction of the force. Consider the diagram. The force acting on the piston side. The piston moves reverse on the reverse side through the force acting on inside of the cylinder. Okay. Work done when a spring is compressed or extended according to the Hooke's law. Okay, students, what is meant by Hooke's law? Hooke's law is nothing but in elastic limit, the stress is directly proportional to the strain. Okay, the next topic is heat. Heat is one form of energy. The energy transfer between a system and its surroundings is called as heat if it occurs by virtue of temperature difference across the boundary. Heat energy moves from hotter body to colder body upon contact of the two bodies. Okay, students, what is the difference between heat and temperature? Does anybody know? Okay, heat is a one form of energy and temperature is a degree of hotness or coldness of the particular element. Okay, next the law of thermodynamics. The first basic one is zeroth law of thermodynamics. I am just briefly explaining the zeroth law of thermodynamics. It is formulated and labeled by R.H. Fowler in 1931. Okay, what is the law of zeroth law of thermodynamics? When the two systems are in thermal equilibrium, the third system are in thermal equilibrium means then they themselves are in also in thermal equilibrium. The next topic is types of thermodynamics. It classified into basically two types. One is statistical thermodynamics and classical thermodynamics. Statistical thermodynamics also called as microscopic thermodynamics. Here the approach is consider that the system is made up of a very large number of discrete particles known as molecules. Thus molecules have different velocities and energies. The values of these energies are constantly changing with time. In macroscopic approach, in other words, this approach to thermodynamics is concerned with cross or all behavior. This is known as classical thermodynamics or macroscopic approach. The analysis of macroscopic system requires simple mathematical formula enough. Thank you.